In this lesson, we're going to look at graphing linear equations. We should be able to identify and graph a linear equation. This is an example of a linear equation that has been graphed. You can see here, this is a straight line on this graph. That's why it is a linear equation. Another example here of a linear equation. Before we can actually graph an equation, we use the equation to create a table of ordered pairs. We put them together in XY ordered pairs, and that's how we are able to graph the equation. Let's take a look at a little definition here. If an equation is linear, then you have a constant change in the y value that corresponds with a constant change in the y value. Let me give you a very simple example to try to explain that. If you go to a convenience store and you want to buy some candy, or you want to buy a candy bar, and you buy one candy bar and the candy bar costs, let's say one cost 50 cents, then you would buy two and it would be $1. You notice that it's a change. You doubled the x value and you also doubled the y value, or you increased it 50 cents here, you increased it 1 here. If you increased it here again to 3, you would increase the 50 to $1.50. So the y value goes up 50 cents each time, and the x value goes up 1 each time. So that is a constant change in the x value and the y value. Let's take a look at an example of actually graphing a linear equation. Here's what an actual graph of a linear equation looks like. Here's the straight line, which represents the equation that has been graphed. And then this diagram shows you that you have a constant change in the x value that corresponds with a constant change in a y value. Over 3 up 2 every time. Over 3 up 2. If we were to write that out, here you see that we have a 3 here, over 3 in the x value, and a positive 2 for the y value. Over 3 up 2. So that's a constant corresponding change over 3 up 2 every time. It creates a linear equation. Okay, so in this example, it wants us to graph the equation and tell whether it is linear. And this is the equation that we will be using, y equals 3x minus 1. So we are going to create a table of ordered pairs by plugging in a value for the x, working it out, and then determining the value for y. So we input a value for x and we get an output of the value for the y. So for the x value, we just need to pick some values, and what we are going to use, we are going to use a -1, a 0, a 1, and let's go ahead and use a 2. So what that means is we are going to multiply 3 times the input x value minus 1, and that's going to give us the y value. And we're actually going to do that every time. 3 times the x value minus 1. And we are going to begin by plugging in a -1 here. When you multiply a positive 3 times a -1, you get a -3. And then -3 minus 1 is -4. So you end up with an ordered pair. The x you inputted was a -1. And when you worked it out, you ended up with a y value of -4. That's your ordered pair that you're going to graph. Do the same thing. We plug in a 0. Of course, anything times 0 is 0. 0 minus 1 is -1. So when we plugged in a 0, we get -1. Another ordered pair. Now we're going to plug in the value, x value of 1. 3 times 1 is 3. And 3 minus 1 is 2. So we have the ordered pair of 1, 2. And then last, we're going to plug in a 2. 3 times 2 is 6, and 6 minus 1 is 5. So that ordered pair would be 2, 5. 5. Now we have enough ordered pairs to graph and determine if it is a linear equation. So let's go ahead and remember what our ordered pairs were. We had a -1, -4, 0, -1, a 1, 2, and a 2. So our x values will be graphed on the x-axis. We always start at 0, and positives tell us to go to the right, and negatives tell us to go to the left. Let's remember real quick. Let's go and write that out. This is our x-axis, and this is our y-axis. So then our y values tell us to go positive, or we go up if it's positive, and from 0, 0 we go down if they are negative. So let's go ahead and plot our first ordered pair, which is at -1, -4. So we start in the middle at 0, 0, and we go to the left 1, and we go down 4, and that's where we finish, at -1, -4. Our next ordered pair is at 0, -1, so we start at 0, 0. We do not go left or right at all, and then we go down 1 at -1. Our next ordered pair is a +1, +2, so we start at 0, 0. We go to the right 1 for the x, and we go up 2 for the y. There's our third point, and finally we have a 2, 5. So we go to the right 2, and we go up 1, 2, 3, 4, 5, which is here. And you will see that these form a straight line. My drawing may not be straight, but the ordered pairs are in a straight line because this is a linear equation. We have another example here I want to take a look at. The equation is y equals 2x minus 1, and we're going to graph it as well. So we're going to, again, plug in some x values, and we're going to end up with some y values. Let's use -1, 0, and 1 for this one. And again, our expression is 2x plus 1. So we're going to have 2 times -1 plus 1. We're going to have 2 times 0 plus 1. And 2 times 1 plus 1. So on our first one, 2 times a -1 is a -2, and a -2 plus 1 is a -1. So we have an ordered pair of -1, -1. And then we have 2 times 0, which is 0 plus 1 is 1. So when we plug in a 0, we get a 1. That is another ordered pair. And then finally, 2 times 1 is 2, and 2 plus 1 is 3. So when we plug in a 1, we get a 3. Now we need to take this set of ordered pairs and we need to graph it. So our ordered pairs were -1, -1, 0, 1, and 1, 3. When I graph these, we have a -1, -1, which is right here. We have a 0, 1, which is right here, and we have a 1, 3, which is right here. And these are in a straight line, another linear equation. Now let's take a look at a word problem. This word problem says that in an amusement park ride, a car travels according to the equation d equals 1,250 t, where t is time in minutes and d is the distance in feet the car has traveled. Okay, what that's saying, first of all, we're going to be using this equation, and the d represents the distance the car has traveled, and t is the time in minutes. So we're going to multiply 1,250 feet per every minute. And the chart below, it says, is below is a chart of time that 3 people have been in the cars. So we have Ryan, who's been in his car for a minute. Greg has been in his car for 2 minutes. And Colette has been in her car for 3 minutes. So we're going to use this equation to determine a relationship between time and distance of the cars and how far each person has traveled. So we're going to use this equation and plug in these x values. So again, here's the equation. If we wanted to rewrite it using y equals, then we could say it's y equals 1,250 x. Again, x representing the time, 1 minute, 2 minutes, and 3 minutes. And then we're going to figure out what y is by plugging it into 1,250. So we multiply the first one times 1. And when we multiply 1,250 times 1, we're going to get 1,250. And then when we plug it in 2 minutes, we multiply the 1,250 feet times 2 minutes. And we're going to get 2,500 feet. And then when we plug in the 1,250 times 3, we're going to get 3,750. So that is our ordered pairs. 1, 1,250, 2, 2,500, 3, 3,750. And then when we graph it, it looks like this. So here's our graph. You can see there are no negatives. The reason there are no negatives is because you can't travel in a car at an amusement park in negative time. So obviously it's all positive. We have 1 minute, that's at 1,250. We have 2 minutes, that's at 2,500 feet. And 3 minutes is at 3,750. And we do have a linear equation. And the reason we have a linear equation because it is a constant change. Every minute the car has traveled 1,250 feet.
Made with Doodlecast Pro.